In section 10.2, we'll talk about regression. And what that means is we're actually going to be looking for the equation of the line that best fits our scatter plot data. So, when we were talking about this back in 10.1, we said something had a positive correlation if it was shaped like a line with a positive slope. And we said it had a negative correlation if the data was shaped like a line that had a negative slope. So our job in 10.2 is actually find the equation of the line that best fits the data. That is called a regression line, or it's also called a line of best fit. Now there is some good news. Our calculators can find the equation of our regression line for us. Okay, so remember, lines look like what we see in the next page, which is y equals mx plus b. That's what our regression equation lines will look like, except for we're going to put a little hat. That's that little kind of part of a triangle on our y here. We're going to put a little hat on our line, and that's just because the line is going to represent our sample data. So how are we going to have our calculator do this hard work for us? Well, let's look at an example first. So in this first example, we've got lemon imports and the crash for fatality rate that we're going to compare those two things. So the first set of data will be our X's, and those will get entered into list 1. And our second set here will be our Y's, and they'll get entered into list 2, just like what we did in section 10.1. So we'll make sure our first set goes into our list 1 as our X's, and our second set goes into our list 2. It'll be our Y's. How did we do that before? Well, before, how we did this is we hit our stat key, then we just chose edit, and we put all of our information that was from our first group into list 1, and we put all of our information from our second group into list 2. And then we went and hit our stat key one more time, and we went over to test, and we ran a linreg t-test. We are going to do the exact same thing all over again. Nothing else is different. It's just what we're actually going to take from the linreg t-test is different. Before, we were using our p's and alphas, or we were using the R, the test statistic, to figure out where it fell with the critical values in a rejection region. Now what we're going to actually look at is taking the information that was below the T and the P that was on the first page. We're going to look at taking the A and the B, because they can be plugged into a line y equals a plus bx. And this line is going to be our regression line. So they're finding all of our information for our line for us using the calculator. So for this example that we're seeing here, what we would do is we'd take the B and plug it in for the B. That's our slope that goes in front of the X. And we would take our A and plug it in for the A here, which is going to be our y-intercept. And what it would look like is y equals, let's see, it's got the A coming first, so 16.49 plus, then we have actually a negative B, so let's do a negative 0.003, which is in front of our X. Now, generally speaking, we are not used to seeing our equations, if we're used to seeing these in math classes, with the x last. So we may want to rewrite this, it's up to you, as y equals negative 0.003x. And that 16.49 is positive, so plus a 1649. Because then it looks more like what we're used to from our math classes. It looks like slope-intercept form, y equals mx plus b, where remember from our math classes that m stands for whatever's in front of the x, which is called r. Remember, m is our slope. And then this b at the end, if you remember what that is, the b at the end here is your y-intercept, where you intersect the y-axis.